Yeah, so my talk is titled Level Up Your Data Lake to ML and Beyond. I'm actually going to spend quite a little time talking about ML, mostly talking about what it takes to do ML, which is kind of the hottest buzzword around. Let me introduce myself. My name is Katz. I work full-time on a project called LakeFS. If you go to github.com/treeverse/LakeFS, you can find it. It's essentially a way to version an object store. So think of it as kind of like the bastard child of Git and S3 in a way. Prior to that, I was VP R&D at a company called SimilarWeb, which is an analytics company managing multiple petabytes of data on object stores of all kinds, deleting some of that data by mistake. That's a badge of honor that I carry with me, just over 1 petabyte, not that big of a deal. Besides that, just over 15 years of experience working mostly in the data field, mostly around analytics, and now with LakeFS also looking at the entire landscape, including ML. I also want to introduce our mascot, which is nicknamed Lottie, and it's an axolotl or an axolote or ajolote, or I'm probably offending everyone here by not knowing how to pronounce this correctly. So I'm Israeli. Apologies for my terrible accents in all languages. Lottie is VP of Cuteness for the project. It's her logo, and she's great, and she'll walk us through the presentation as well. Yeah, so what I plan on talking about today is my take on data lakes as they are at their current state. We saw a few presentations today of how these look in the real world, which is really interesting. And the recurring theme would be kind of the human factors behind the data lake, so not just the data itself and its scale, but also like the teams and the peoples and the process that have to go into creating something like that. So I'm going to cover some of those challenges and then suggest a few tools. Spoiler, LakeFS is one of them, to help with some of these issues. So before that, I am a human, unlike Lottie. This is my actual desktop. I have my computer here. If someone needs proof, I can show you that. This is what it looks like. And I consider myself reasonably organized as a person, but it ends up looking like this every time. And then I clean it up, and I look at it, and I'm like really proud of how clean it is, and then 2 months later, it's this again. And we're all human, right? So to some degree, we're messy creatures, especially when we're trying to figure out something new and do something innovative. Chaos is kind of a part of that, in a way. A data lake, in essence, is kind of this, but multiplied by the number of people that you have. If you look at the exponent around data scientists, they tend to be worse. I don't know why. Maybe it's like inversely related to their intelligence. I don't know. But we are messy creatures. And as this scales up, the complexity rises, and it becomes something that's really hard to manage. Again, I deleted just about a petabyte of data by mistake. It gets really complicated, knowing just which data types you have, where it sits, which one is serving which team. Making some order of that chaos is really, really hard. And then we end up with something that kind of resembles this. This is not an actual depiction of the data that we have on S3, but it's not that far off, right? So we see that we have like a prod v1 and prod v2. Which one is actually being used? I don't know. And then we have stuff like test and test blah. And obviously the one serving production is test blah, so don't delete that. It's really hard, right? We're still humans at the end of the day, right? And even if each directory represents thousands of data sets across Delta tables and parquet files, still a human had to name that table, and they decided on test blah. So there you go. So if that's the case, let's kind of try to recap on the challenges that this brings. So the first one has a lot to do with ML, right? So we're trying to transition from doing not just analytics, but try to extract more value. I think someone said that this is the new oil. How can we extract more value from the data that we do have? So a key challenge there, especially if you talk about ML, is how do I reproduce pretty much anything, right? So I have data in an object store, or in my Snowflake, or in my data warehouse, wherever it is. I'm running an experiment. Say I want to pass it on to my colleague and show them this nifty model that I just built. And I say, if you want, this is how I trained it. And then they try to do the exact same thing, but they get a different result. And the reason for that is test blah, right? Someone changed it in the meantime. That was my input data. I read from test blah. Now it's test blah v2, and the data is completely different. So I have no way of reproducing the experiment that I ran. And without being able to reproduce, it's impossible to debug. This is also true for production. So let's say I have this hourly job, and one every 3, 4, 5 hours it fails. Let's say it's an ETL transformation. It failed, and now I want to fix the bug that causes this thing to be flaky. But if I run it again, now it's green again, right? Because data keeps changing. How do I know that I solved something that actually fixes the problem? So this becomes really hard. And one of the main challenges here is that while we do have like dev and test environments for our code, we don't have something similar for our data, right? So if I look back at my example from SimilarWeb, the reason I deleted just over a petabyte of data was because we had this really nice, like naively named job called retention, which deletes data. We had a dev stage environment for the data itself, which was a sample of the production data. Right? No one wants to pay for another set of 8.5 petabytes of data just to test retention. And then there was no place where I could actually run this job after modifying it to validate that what I'm doing is actually safe. Right? Because if I run it on sample data, even I didn't really trust the result that I saw there. Yeah, okay, it was successful, but it's a much smaller subset and much less complex. How do I create a dev test environment without testing stuff that is so dangerous directly on production? And then production safety, right? This is my badge of honor. So let me introduce LakeFS. So as I mentioned, you can think of LakeFS as kind of like Git meets object stores. So it's a layer on top of existing object stores. So LakeFS can be deployed on top of AWS's S3, Azure Blob, Google Cloud Storage, or anything that's kind of S3-like. So essentially, if it's an object store, chances are you can run LakeFS on top. And then you can take all the existing tools that you have, whether it's for machine learning, analytics, or anything else that communicates with that object store, and essentially let them go through LakeFS in order to get the versioning capabilities. All right, so in the example here, you can see that instead of going to some bucket / some collection, I'm just adding a name of a branch in the middle. This hits my LakeFS endpoint, which translates this to a set of objects that belong to that version. And the way this works behind the scene is that LakeFS doesn't actually have to copy the data every time you want to create a branch. It's essentially creating a set of pointers to the data that existed at the time that branch was created. So you get all the benefits of Git, right? So you get cheap branching, you can do commits and merge and add like hooks to validate stuff before you merge into your production branch. You get all that power, but for your data instead of your code. So LakeFS is open source. So you can check it out on github.com/treeverse/LakeFS. There's also a very vibrant Slack community for people from all across the world using the project and different companies. And if you want to try it out for yourself, there's a quick start, which I will link to at the end of this slide. Essentially, it's a Docker run, and you get something local that you can start experimenting with, run your jobs against that local LakeFS, and start experimenting with that. So let's see how we can use something like LakeFS and those Git-like capabilities that it brings in order to solve some of the challenges that we discussed. So we talked about reproducibility, right? I want to be able to run the thing that I ran yesterday and get back the same result. So imagine that I probably already have like a Jupyter notebook that's connected to Git, or I'm versioning my code in some way. With LakeFS, I can also version my data. And let's say I had a very successful run yesterday. I'm very happy about the result. I can simply tag that snapshot of my data lake, right? However many petabytes it may be, and essentially treat that as my input. All right, so I know that given the same code and the same input data, as long as the process is deterministic, I should get back the same result. And I can actually record all the information about my environment, which version of the libraries that I was using to train, the version of the code that I use. I can track all of that within LakeFS and attach that as part of that tag. All right, so I can say that ML trained 2022-06 also is attached to all this information that might be useful if you want to recreate that same scenario later. And then, once I have this tag, it's just like any other reference within LakeFS. I can address it by reading it from Spark or TensorFlow or whatever other data utility that you're using. LakeFS works with the vast majority of them. Let's talk about dev test then. So this is kind of a GIF from the LakeFS UI. LakeFS is available through a UI interface, a command line called LakeCTL, as well as a bunch of SDKs, anything from Spark, just Java and Python, Boto, anything that you might think of data is being accessed through, you can use LakeFS with. In this example, I'm just showing the kind of the branch picker. So you can see that I don't have to check out my data into some machine in order for it to be usable. So I can have multiple processes, distributed systems, reading and writing to different branches at the same time. All right, so this is a key difference from Git, where mostly you're working locally, and it's kind of human scale. Here we're talking about machine scale. I probably don't want to check out petabytes of data just to run a job. So I can just pick and choose whichever branch or commit or tag I want to use and address that directly. Why is this helpful? First, because branches are copy and write, so you don't actually have to copy any data just to create a branch. So I could have my own dev environment. You guys can have your own. It scales very well to the size of the organization, right? So even if you already have a staging environment, you probably have one of those, meaning you can only test like one thing in isolation at a time. With LakeFS, just create as many branches as you need and then decide at the end whether you just want to throw them away because the results are not interesting or you want to merge them back into your production. Another key thing that this enables is that you can introduce hooks. Just like you have CI/CD for your code, you can essentially have the same thing but for your data. So you can say my main branch is protected, meaning my data is protected. And I can only merge new data into that branch once it passed this series of codified tests that must be validated. So here, just kind of a silly example of what this can do. So here, let's say I kind of determine I have a rule within my organization. We only want parquet files. We don't want CSVs or TSVs because these are really hard to manage. So I would just have a simple kind of pre-merge hook on my main branch saying, this formats are allowed, but here you're introducing random.csv. That's a format that we don't allow, and then this merge atomically fails, right? So it's not that you're left with some inconsistent state. Either everything gets merged or nothing, right? Just like in Git. And then later you can go and see, okay, why did my merge fail? Okay, I was trying to introduce a CSV. That's not allowed. And just like we did this kind of naive validation, you can do any type of validation you want, right? So you can look at the statistical qualities of the data itself. You can look at the schema to make sure it's backwards compatible. You can define data contracts, saying these are the columns that must be defined and these are the way that they look. You can do whatever type of check that you want and introduce that as kind of a gatekeeper to your production data. Right, so you can get to determine the rules of the game. And if something does go wrong, right, again, we're human. These tests are not going to cover everything, just like our unit tests don't have 100% coverage. Just like in Git, you can always just go back one commit, right? So thinking about me deleting all those essentially millions of objects, all I wanted was that silly revert button, right? Just to be able to like take me back to the last known good state of the system 5 minutes ago before I ran this really stupid thing. Where's that for my data lake, right? And we were able to restore everything. We did like object level versioning that S3 allows you to do, but that means restoring one object at a time across millions of objects. Just knowing which objects got deleted by mistake was a challenge. All I wanted was that revert button. Yeah, so essentially we get the power of reproducibility, right? We can just refer back to a historical commit, and commits are guaranteed to be immutable, right? So I can rerun the same thing, get back the same results. We get the ability to run actual dev test environments without having to copy and manage multiple copies of the data. Just the operational overhead of doing that is really large. And then we get production safety. We get that big blue revert button that we always wanted. Yeah, so to learn more, check out lakefs.io. That's kind of the homepage for the project. We also, as I mentioned, have a really vibrant Slack community you can check out with companies from all over. And of course, feel free to check out the project on GitHub. And thank you.
My first question is, who came up with the design for the LakeFS logo?
Oh, definitely not me, I can tell you that. So we were actually really trying to think about like what best represents that. Our initial idea behind it was something that lives in a swamp, because that's where we are. It's not really a lake, it's a swamp at that point. And that creature, whose name I'm not going to pronounce again, is essentially kind of this mythical, cute beast that lives within your lake, keeping it safe. So that's how it came to be. And that's credited to our designer.
Oh yeah, shout out to the designer, because
Yeah.
I think it's so easily recognizable. And I think it's important, though, too, is that as much as we're talking about things that sometimes are not tangible, or that we can't really, we can't touch, we can't sit next to it, building something like that that people can relate to more and also have fun at the same time, I think it's very important. I think the success of LakeFS speaks for itself in terms of how the community's grown and getting people energetic. What have been, in terms of as that's grown, because I think it's grown quite a bit since I first interacted with someone from Treeverse back in the Data on Kubernetes community days, is that how do you, in the same way as a company, a project, how do you sustain that growth? How do you not become a victim of your own success?
Yeah, so that's a good question, and I think it's even a bit broader than that. So kind of having the duality of building a business on top of something which is essentially community-driven and open source, that's kind of a good tension to have in a way. So we have a community that keeps us very honest, right? So we'll never take away a core feature of LakeFS because we know it's going to upset the people that help us build this thing along the way. So I think, as everything, I think it's a recurring theme here, it's all about the people. And just being respectful of the people who got the project this far and are actively contributing. We don't want to miss out on that, right? We can't build something like LakeFS without having a community involved.
Great point. And yesterday, talking to some folks from the CD Foundation, is that understanding behind any of the big releases or big launches or things like that, the amount of small actions that have to be taking place from individual contributors, and why are they going to be motivated to show up and make those things happen? I think it's a great answer. So thank you very much, Oz. Pleasure.
Thank you.